Answer key 8.28 part 2. You can watch me do the problems. Remember with the video to pause often, speak out loud and rewind, and use the gear button to slow it down if you need to.
Will boron lose or gain electrons? Remember, atoms want to either 8 or 0 in their outer energy level. So over here on the left side, we see boron atom, 5 protons and 5 electrons. The protons are the little red ones in the middle, and the electrons are the blue flying around. And so we see 1, 2 in the first energy level and 3 electrons in the outer energy level. 3 electrons, is that stable? No. 8 is stable or a full energy level, so that's unstable. It might be good to remember that. And over here in this area on the right, they want us to draw boron as an ion, and ions are stable because the atom will lose or gain in order to become stable. So over here, we're going to draw the stable ion, just to keep that straight. On the other hand, atoms do not have a charge because they have equal protons and electrons. So in this case, this atom is unstable, but it has no charge. We're going to draw the ion, and it will have a charge. So now we have to decide, is it going to lose those 3 or gain 5? And look at what happens if I kind of erase these 3 on the outside, like they're being lost or given away, lose 3. Now look at how the atom has a full energy level, because remember that first energy level can hold only 2. So it has 2 in its outermost energy level, and so it is stable if it were to lose those. Another way it could become stable is if it gained 5. But gaining 5 is a lot more work than losing just 3. So remember from our lesson, they're going to do what's easier for them. So losing 3 is less than gaining 5. So now I'm going to draw that over here. I'm going to use just letters and numbers. Oops, got to make a skinnier one here. So instead of the red dots, I'm just going to put 5 protons. I'm not going to worry about neutrons, but the protons are important for figuring out the charge. So there's my nucleus, and now I'm going to just change color for my energy levels. So if it has lost 3, it's still going to have 2 in its first energy level. So I'm going to draw those here. And then the other 3 that were on the outside are gone. So now this is stable, but it does have a charge. Let's see why. It has 5 protons, and now it only has 2 electrons. And so 5 positives plus 2 negatives means overall its charge is now 3 positive, or positive 3. Another way to figure it out is to say, well, it lost 3, losing is positive, and so it lost 3, it'll be a positive 3. So it's stable, but it does have a charge. Now it doesn't ask you this, but is this a cation or an anion? It's positive, so it's a cation. And that's just a little bit of vocabulary. All right, magnesium. Which is it more likely to do, lose or gain electrons? So we see a magnesium there with 12 protons and 12 electrons. So let's look at the electrons carefully. We see 2 in the first energy level, and then we see 8 in the second, and then 2 in that outermost level. So to become stable, it would either have to lose 2 or gain 6. Well, they never do more than 1, 2, or 3. So losing 2 is easier than gaining 6. And so you can see how it looks in this nice drawing. Notice how if it loses 2, that outer level then is gone, and the one underneath has a full energy level. And it looks like a noble gas with 8, even though it still has 12 protons. So we're going to draw that over here. So we'll use 12p in the middle, and that's my nucleus. And then we're going to need a first energy level for 2 and a second energy level for 8. But the third energy level with those 2 is gone. So now I'm going to show these. So we can put the electrons in pairs if we want. Makes it a little easier to count. So there's 2 in that first energy level. And then 1, 2, 3, 4, 5, 6, 7, 8. So those are the 8 that we see over here in the second energy level. These, like that one. And then I don't have any more because it lost those 2. Now they do want us to put the charge, so if it has 12 protons and now it lost 2 electrons, so it only has 10 electrons, what is the charge? Well, 12 positives and 10 negatives means it's positive 2, or sometimes we usually say 2 first. And remember again, that makes sense. Double checking losing is positive since it lost electrons. It is now a cation. Now which one is stable and which one is unstable? Well, the one over here, the atom, is unstable. So that's why when it can, it will always lose 2 and become stable. Last one, which is fluorine more likely to do, lose or gain electrons? So we see a fluorine atom here with 9 protons and 9 electrons. Let's look carefully at the electrons. 2 in the first, and then 7 make the 9. 7 is not stable, so hopefully you're starting to see that losing 7 would be a lot, right? Even though that might be stable, losing 7 is a lot. It's easier to just gain 1 to get to 8. So we're going to draw it gaining 1. It still has 9 protons in the middle. I guess I changed my color there, but I think that's okay. I'll just reverse it. Now the first energy level is going to have 2, and I'm going to need a second energy level. So now I'll put in my electrons, 2 in the first, and then 8 in the second. And it had 9 protons and 9 electrons, but now it gained 1, so it's 9 protons and 10 electrons. So what is the charge? 9 positives plus 10 negatives means the charge is -1. Gaining, it gained an electron. Gaining is negative, so it's an anion. But it is stable now. And over here, it was unstable. Now, notice, maybe my coloring doesn't help it, but these 2 atoms, the magnesium ion, I should say, this one up here and this one here, have the same electron configuration, 2 and then 8. And they're both stable. They're still different because they have different protons, and one is a +2 and one is a -1. But they both have that stable configuration of one of the noble gases, in fact, neon, which has 10 electrons itself. So they both have 10 electrons here, even though they're different ions.